let's do section 8.5, the last section of chapter 8 on absolute value equations and inequalities. So our two objectives today, solve absolute value equations and solve absolute value equalities. There's a lot that is involved in this, and you will need to look back in your notes. So make sure that you take good notes in this section and have every kind of example down, and we'll cover at least one example of every type, and you'll see what that means here at the end. But for absolute value equations, those are equations that contain an absolute value. So for example, if I have the absolute value of x equals 2, absolute value of 2x minus 5 is equal to 7, 6 minus 2x, the absolute value of that, minus 5 equals 2. Those all are absolute value equations. Just notice this last one doesn't have the absolute value alone on the left side. That is a requirement to begin to try and solve the absolute value equation. So keep that in mind, and we'll talk about that more in a while. But consider this equation here, absolute value of x equals 2. That has two solutions. Why is that? Because we know that the absolute value of 2 is 2, and the absolute value of negative 2 is 2. So 2 and negative 2 are solutions of that equation. So here's some general rules. If I have the absolute value of x, or an absolute value solved for already, and I have some whole number k, or just some number k, it doesn't even have to be a whole number. If k is greater than 0, I'm going to have two solutions. Either x is going to be equal to k, or x is negative k. If k is equal to 0, then, well, the absolute value, is, I can just drop those, and x is just equal to 0. And if k is less than 0, then it has no solutions. Why would it have no solutions? Well, because the absolute value of x is always positive, okay, and it can never be negative. So absolute value of x can never equal a negative number. That's why this has no solutions. So I'm going to go through examples of all those here in just a second. So solve the equation. Actually, I'm going to just click through this one because I forgot to edit it here. But if I have absolute value of x equals 38, again, k is positive. This is positive. So I'm going to have two solutions, either positive 38 or negative 38. Okay, negative 38 and 38. But if absolute value of x is negative 4, that can never happen, right? We can never have a negative absolute value. So that is going to have no solutions. All right, let's solve the next one symbolically. So I don't just have absolute value of x in here. I have absolute value of 2x minus 7. So I'm going to have to do a couple different things for that. I'm going to have to rewrite that equation. And I'm going to have to write it again, right? Because if this was just absolute value of x equals 5, I would have x equals 5, or I could have x equals negative 5, right? Both of those solutions work for that. So all I'm going to do here is I'm going to rewrite the same thing that's on the left with the or statement. And I'm going to say 2x minus 7 equals 5, or 2x minus 7 equals negative 5. And then I'm going to solve these two equations, and those are my answers for this, okay? So let's solve these. I'm going to add 7 to both sides. You guys should be pretty good at solving equations. So I'm not going to really take a whole lot of time for that. That's not the point of this. So if you need more work solving equations, find some extra practice on that. Either use the Learning Center online or whatever you need, okay? And then divide by 2. So x is equal to 6. Or the other solution could be, let's add 7 again. So 2x equals 2, divide by 2, x equals 1. So, so the solutions here are 1 and 6. X equals 1 and 6. You can just put 1 comma 6, that's fine, or 1 and 6. Okay, but it's either or, and an or doesn't matter in this section like it did for the inequalities, okay? It's just say it can be this one or this one, but then there's two solutions in the end. So both 1 and 6. If I was trying to graph that, okay, It would be, and I'm not going to ask you to graph these, but I just want you to understand that it's when this absolute value, which is always shaped like a V, when that is equal to 5. Well, 5 would be, where would it be on the y-axis? 1, 2, 3, 4, 5. So it'd be something like this. Okay, that's a line where where y is equal to 5. And then what is the x value there? So it'd be, well, x, when x is 1, or sorry, what am I trying to say? What are the points where when x is 1, it equals 5? Or, well, it's just at 1, 5. And then x is 6, 1, 2, 3, 4, 5, 6, 5 would be right here. And the vertex would be right between those. That's kind of why I had to do the midpoint formula, right? The midpoint of 1 and 6 would be 3.5, right? You just do 1 plus 6 divided by 2 is 3.5. But anyway, this is kind of what I'm getting at. This is the function. This would be the function absolute value of 2x minus 7. Okay. And then for here, it's where does this equal 5? Well, it equals 5 at 1 and 6. That's kind of the graphing version of this. I'm not going to have you do that, but I just want you to understand what that means. All right, absolute value equations. So what if k is greater than 0? Okay, so if you have a case where k is greater than 0, like we just had, we split it up into two different things. Okay, the only thing here, the new thing that I want you to note is that you must simplify first to make sure the absolute value part, right? So whatever is in the ax plus b is on the left, or is on one side. I usually put it on the left, and k is on the other side. And you break that up into a positive k and negative k, just like we just did. So let's do an example. So this one, we notice that the absolute value is not alone on the left side. So I'm going to add 3 to get it alone. If you were to split this up right now, okay, that wouldn't make any sense. First of all, it wouldn't make sense because you can't split it up into positive 0 and negative 0. And second of all, that's just not how we do it. Okay, we have to solve this first, so that you have to solve it first. Okay, so that the absolute value is on the left, the other value is on the right. Now we can split. Now we split it up. So we say 6 minus x could be positive 3, or 6 minus x could be negative 3. And we go ahead and solve those. So I subtract 6 to both sides. 3 minus 6 is negative 3. And then divide by negative 1. So x equals 3. Subtract 6 again over in this one. And I get negative x equals negative 3 minus 6 is negative 9. Divide by negative 1, x equals positive 9. So really, x could equal 3 or 9. Those are your two solutions. Or 3 and 9, whatever. But again, it doesn't matter. All right, I have another one. Just same thing, basically. Well, not the same thing. I don't have to solve anything here. All the absolute values on one side. I have a number on the other side. But in this case, I'm just going to have to do some simple fraction clearing. So I'm just giving you guys some practice with that. So again, rewrite. So just drop the absolute value, rewrite it, and then rewrite the same thing that's on the left, but make the right side negative. Now solve these. I'm going to start with this one. I need to get rid of the absolute, or not the absolute value. I need to get rid of the fractions. So what I'm going to do here is I'm going to multiply by the least common multiple of 2 and 8. Least common multiple of 2 and 8, which is 8. So I'm going to multiply this by 8, and I'm going to distribute that to the fractions. So distribute 8 to 1/2. 8 times 1/2 is 4. Keep the x minus 8 in the parentheses. And then 8 times 7/8, just cancel the 8s. That's just 7. If you don't believe me, multiply it on your calculator. Okay, you'll get 8 times a half is 4, 8 times 7/8 is 7. Now, we can, we don't have to worry about fractions anymore. We cleared the fractions. Let's distribute. So 4 times x, and then 4 and -8. I have to add 32. So I get 7 plus 32 is 39. And then divide by 4. Again, I'm skipping some steps because solving equations is not the point. Okay, you should know how to do that. At least these basic ones. Okay, it is good practice if you need more practice, but my point is how to split these absolute values up. And then the other one, again, let's multiply by the LCM. So let's multiply this by 8. And we're going to get 4 times x minus 8 equals -7. Distribute 4x minus 32 equals -7. Add 32, so we have positive 25. -7 plus 32 is 25. And then divide by 4. So my two answers are 25 over 4, that's the smaller one, and 39 over 4. All right, let's solve these two. A little bit of a hint, these are special cases. So k in this case is negative, okay? What happens with that? You can look back, but an absolute value can never be negative, okay? This can never equal -7. So the absolute value of 3x minus 2 cannot equal a negative. So what does that tell us? This tells us that there's no solution. Why? Because k in our kind of equation there is less than 0, right? And we know that the absolute value is never negative, always positive, because it means distance from 0. Absolute value means distance from 0. You can never have a distance from 0 that's negative. This one, you have this is equal to 0. That can happen. And when that happens, there's no point of splitting it up because you're not going to split this into 6 minus 3x equals positive 0 and 6x minus 3x equals -0. That doesn't make any sense. So all we have to do is just drop the absolute value, set it equal to 0, and solve. So I'm going to subtract 6. So -3x equals -6. Divide by 3, x equals 2. All right, let's find out what happens when we have two absolute values that equal each other, okay? Basically, you're going to drop the absolute values, both of them, to have one equation, and then you're going to have another equation where you keep the left side, but you will put the right side in parentheses, and then you distribute and solve. So let's kind of model that. So we have two absolute values that are equal to each other. You're gonna just drop the absolute values, the absolute value brackets for one of these. And then the other one, you're gonna keep the left side, so keep the 3x, and then put the entire right side in parentheses on the other one, okay? Why do we do that? Because it could be, so one of them could be positive, or this could just stay positive, or it could be all right negative, okay? So then we just solve this, kind of solve this backwards. Let's subtract 2x from 3x. That's just x. And I'm left with -5. And if you miss some of these, you can always pause and go back to what I said. Okay, if you kind of missed that. All I did was 3x minus 2x, right? I subtracted the 2x to this side. So one of the solutions is -5. And then let's distribute over here. So this is just going to make the signs flip inside the parentheses, -2x plus 5. Let's move the -2x over here, which is going to make this, I'm going to add it to both sides. So I have 3x plus 2x is 5x. Bring down the 5, divide by 5, x equals 1. So your two solutions there are 5 and 1. All right, moving on. This gets a little bit more tricky when we have to break this up. Basically what this means, you're looking at if this is a less than symbol, less than, I say it's a less than. And we learned last section that if you have an and, you can split it up like this, where you can make it this compound inequality where it's a single inequality. Okay. If it's this guy, let's do that in red. Let's do that in red. If it's a greater than, so if it's a greater, then I say it's greater, okay, and less than, okay? I know it's kind of weird, but if it's a greater than, we can break it up into two different things like this, kind of like we just did. And I'll model that here in a second. Okay, I use this from the book. I don't really like this necessarily, but this is how I do it. And just again, when you're doing this, take good notes, write down examples on a test or something. You're going to model that example, okay? Or on a quiz or whatever your homework, okay? All right, so this first one is just like we've been doing, it's just an equal to, okay? So what does that mean? All that means is I'm gonna take this, I'm gonna drop everything for one of them, and then I'm gonna make the 5 negative for the other one, and then just solve. So I'd have negative 4x equals 5 minus 3 is 2. Divide by negative 4, I have negative 1/2 after I do 2 divided by negative 4. Right, 2 divided by 4 breaks down into negative 1/2. Really, the negative should be, it doesn't really matter where the negative is. It could be with the top one, it could be with the bottom one, it could be even, it doesn't matter. This one, I'm going to subtract the 3 to both sides. So I have negative 4x equals negative 8, right? 5 minus 3 is negative 8. Divide by negative 4, I get x equals 2. So I have my two answers there are negative 1/2, sorry, and 2. Let's see, what did I want to do? Oh, yeah, okay, so the less than one, this is when we can make it a single inequality. So I can make this a negative 5 less than 3 minus 4x less than positive 5. So I have this part as the same as this, but I just have this negative 5 over here, and I'm working between those things. And again, I can do that because of this thing, which is a less than or less than, right? For and, it's between, or what they both have in common. So now I can solve, okay? So I can subtract 3 from everything. I'll write that out because we aren't that used to solving these. So I minused everything by 3 except for this, right? I can never take 3 from an x term. But then I divide everything by negative 4. Oh my, I divided by 0. We have to do what? Now we're back to switching signs. Okay, just like last section. So negative 8 divided by negative 4 is positive 2, but this sign flips. Flip the signs. Okay, so 2 is greater than x is greater than 2 divided by negative 4 again is negative 1/2. And then what I can do is I can just rearrange this, put it back in its proper form. Whoops. Put it back in its proper form where the smaller values on the left, the larger values on the right. I just flip these signs back, but it doesn't change anything. Okay, it doesn't change anything because the arrows are still pointing to the proper things. Now let me do C. I don't know why I left A and B in there. This is a greater than, right? It's a greater. It's a greater than 1. So when it's a greater than 1, what you do is you drop everything from one of them, leave it the same. And then you have or, the other option, but you have to flip the sign. Okay, so notice this part. Notice this part that you have to flip. You have to flip the sign and make this negative. Okay, 2 different things you have to do for the second one. Switch the sign, make this negative. Or if it's like a whole bunch of things, you're going to have to negative parenthesis, and then you're going to have to distribute the parenthesis. Or no, not distribute the parenthesis, distribute the negative inside of the parentheses. But let's solve these now. So I subtract 3 for this one. So I have negative 4x is greater than 2. Divide by negative 4. Oh, divide by negative 4. Switch the sign or flip the sign. And 2 divided by negative 4 is negative 1/2. Or subtract 3 again. So I have negative 8. Negative 5 minus 3 is negative 8. Divide by negative 4. So flip the sign. Negative 8 divided by negative 4 is positive 2. So my 2 answers are these guys, negative 1/2 or 2. Now, it may ask you for the interval notation. Whoops, interval notation, like last chapter or like last section. Again, just imagine, that you're on a number line if you're a little unsure, right? You're at negative 1/2, you're going to the left. So you have bracket, or not bracket, parenthesis into the left. And then you're at 2, you have parenthesis going to the right. So I would have negative infinity, starting all the way on the left, to negative 1/2, not including that, union 2 comma infinity. Okay, this is the interval notation. That's interval notation. If it asks you for that, let me see if any of these other ones. Oh yeah, like for this one, the interval notation would have been interval notation for this one would have been negative 1/2 comma 2. Like that. Okay. No interval notation here. I can't do that for those equal to ones, but all right, let's do some more cases here. And again, this is just this is just going to be another greater than case. All right, so kind of ignore some of this stuff. It's kind of overkill. If you don't understand symbols, I never did. I just wanted to see examples. Okay, here's an example. I have the greater than sign. We're going to do the exact same thing that we just did, right? We're going to do the exact same thing we just did because it's greater. So we're going to take this, rewrite one of them, and we're going to say or 3x minus 2 divided by 4 is less than negative 4. And then just solve. So here I'm going to cancel the fraction out by multiplying everything by 4. So 4 is on the left, cancel. I'm just left with 3x minus 2. I just cross cancel them. And then I distribute here to get a 16. Add 2. It's going to give me 18, and then divide by 3. So x is greater than 6. Or again, multiply everything by 4 to get rid of the fraction, to get rid of the 4 down there. So we're just going to distribute, and again, when we do that, we just cancel. So the denominator 4 is gone. And I have negative 16 now over here. Add 2, it's going to give me to negative 14. And then divide by 3. is going to get me to negative 14 over 3. Now, some people ask sometimes like, well, why didn't you switch the sign? Because I was dividing by positive 3. Even though the 14 is negative, I don't have to switch the sign because it's based on what you're dividing by, not if one of them is negative. So that's your answer. And again, if I wanted this in interval notation, it would be negative infinity to negative 14 over 3, parenthesis, union 6 to positive infinity. This would again be the interval notation. All right, let's do a little bit harder example here, a word problem. I'm not sure, I don't remember if I put one on your homework or not, but here's an example. So an engineer is designing a circular cover for a container. The diameter D of the cover is supposed to be 4.75 inches and must be accurate within 0.05 of an inch. Write an absolute value inequality that gives acceptable values for D. Okay, so you might be thinking of this, right? Of course, right? If you have a diameter is 4.75 and it's accurate to within 0.75 of an inch, all you have to do is add and subtract the 0.05 from each of those to get values of 4.7 and 4.8. So it has to be between 4.7 and 4.8. But the point is, how do we write an inequality? Sorry, not an absolute value inequality that gives us that. Okay, so what we do is we have the 4.7 and 4.8. We're just going to say that the diameter is between those. Okay, we know that that has to be the case, right? And we just do. So actually, what we're going to do is we're going to work with this 4.75, and I'm going to take that away from all three of these. Okay, and this will make a little bit more sense when you go through it yourself. But I'm going to take that away from all three of those things. So I have negative 0.05, D minus 4.75, and 4.8 minus 4.75 is 0.05. And then what I do is this is one of those that we have the and, right? This is one of those that we have an and because it's between two different things. So I know that this is going to be a less than, which means it's less than or equal to in this case. So I can take what's in the middle there and just put that in a less than or equal to symbol with the 0.05 because I know that I could write the other one over here with the negative 0.05. So this is that inequality that works. Just making sure I'm covering everything. I got my notes here. So let's do these last two problems. Solve if possible. Well, that's probably a hint that maybe one or both is not possible here. So let's figure that out. So remember, when we do these, we have to solve it first, right? And what I mean by that is we have to simplify it so the absolute value is on the left, everything else is on the right. So I subtract 2, which gives me absolute value 4x minus 3 is greater than or equal to negative 1. Well, we said before that an absolute value can never be less than 1. But in this case, it's always greater than a negative. So actually, in this case, the solution is all real numbers. And again, why is that? Because an absolute value is always going to be greater than or equal to negative 1. Okay, we can't find what it's going to be in this case because this is negative. But what we can say is it's always going to be that. So any x value that I put in here, this is always going to come out positive. It's always going to be greater than or equal to negative 1. So there's no reason to figure out what it can and can't be. It's always going to work. Okay. And remember, for us, when we say all real numbers, we're going to write that in interval notation. negative infinity to infinity. And again, this is because the absolute value, or they want to say that, cannot be negative. Negative and is greater than 1, or sorry, greater than -1 for all x values. So that's A. And then B, absolute value 6x minus 5 is less than 0. Well, what's the problem with that? An absolute value is always what? Oops, is always, it says always greater than or equal to 0. Okay, so there are no x values that satisfy this inequality. So there are no solutions. Okay, so we have two special cases. We have two special cases when we're working with greater than or equal to, or just greater thans and less thans. You really have to pay attention to what these numbers are. Okay, after you solve for the absolute value on and keeping it on one side of the equation. So that is chapter 8. Please let me know if you have any questions, and yeah, we'll see you for the next chapter after this.